All right, good morning, everyone. Today we are going to continue our review of Unit 7. This material here we actually learned on the Friday of the last day that we were actually meeting together. And so I know a lot of you missed that day. So we are going to treat this as if this is not a review, but an actual content teaching lesson. So let's first just take a look at this problem. So Ona took a random sample of 20 soccer teams across Europe and tracked the average number of goals each team scored per match and how many total matches each team won in the 2014-2015 season. Here is a regression output on the sample data. Assume the conditions for inference have been met, use a 0.05 alpha level. So looking at this problem here, hopefully this table looks familiar to you at least, and this is a slope regression table. So if we look at this table from Unit 2, we talked about how this column, the coefficients column, gives us the information to make our y hat equation. So just as a quick refresher, we would have y hat is equal to 14.02x minus 3.64. So in this row here, the constant row, that is our y-intercept value. The coefficient of the constant is the y-intercept, and then the coefficient of this variable here, that is our slope. So looking at this here, we are only looking at the regression. So this is a slope regression test, meaning that we only really care about the slope in this problem. We don't really care about the y-intercept. So the most important thing in this problem is this row here and these values from the slope. So if you were here that Friday, you already have these notes. So if you were not here, please just record these notes now. So our test statistic formula, we know the general formula is equal to our parameter, or excuse me, no it's not, our statistic minus the parameter over the standard deviation of our sample. So we talked about how the statistic, the parameter in a two-sample proportion or two-sample mean is equal to 0. And that is going to be a similar case here where our parameter is equal to 0. So this is in full generality, this equation here. Here, let's just do the actual equation for this problem. So the slope regression test will be a type of t-test. So t is going to be equal to, and this is our slope minus 0 over the standard error. So the standard error is also a way to describe the standard deviation of the sample. Specifically, it's similar to the margin of error. And in this problem, it's going to replace our standard deviation of the sample. So if I were to actually do this problem, the only values that I need are going to be the slope of our, from the table, and that is this value here that we already described, and then the SE coefficient, which stands for the standard error. So this one here, this is going to be the value for our standard error. Now, when we were doing two-sample means, there was also a standard error column for the difference in the mean, and a lot of you asked me, oh, are we going to use this, or is this just useless information? At that time, yes, it was just useless information, but here, this is a value that we're actually going to use. So this is the value that's in our denominator. So here we have 14.02, our slope, minus 0, over the standard error, so 1.15. So our test statistic in this problem is going to be 12.19. So from here, we're kind of doing this a little bit out of order, but let's go ahead and write what our hypotheses would be in this type of problem. So for our null hypothesis, we would have that there is no difference between whatever our variables are, so goals and matches 1. And then our alternate hypothesis is there is a difference between our variables. So since our null hypothesis is saying that there's no difference between goals and matches 1, if there's no difference between two variables, and this is a slope regression test, then our slope would actually be 0 if there is no difference. So that's why we use 0 as our parameter here, and then we use the actual slope from the table for our statistic of sorts. So we have our hypotheses. They've said assume the conditions have been met, so we're good to go there. We've calculated our test statistic. So now, since this is a t-test, we need our degrees of freedom. So in the slope regression test, our degrees of freedom is actually going to be calculated by n minus 2. So the reason why we have 2 here is because we are now dealing with two variables. We're not dealing with just a proportion or just a mean. Those are just one variable. But here, since we're dealing with a slope regression test, we have two variables, goals and matches 1. That's why we subtract by 2. So our n value in this problem was 20. They took a random sample of 20 teams. So we would have 20 minus 2 gives us 18 degrees of freedom. So now I would go to my t-table, and let me just pull that up here.